Good evening, friends, and welcome to Eastern Academy. And today we are into embedded system programming, week 11 and day 3. And so far we had discussed about how to address the passive devices like LEDs or other things. And then we started our discussion with active devices like yesterday we discussed about how to control the LCD controllers. But when it comes to the controller, there are some important things you should know. That is what I'm going to start from today. That is called microprocessor buses. You have to know about what is the bus and why it came. Okay. This topic it will go for a long time, but I'll try to give you some glimpse today. Okay. And the idea is quite simple. That once you understand the idea, you will be able to understand what is this buses, why the buses came. Those are the basically what for these buses. That will give you a good idea about how to choose and what to learn and everything. Also, you know that most of the interviews they asked about these things. Okay. Let us discuss from beginning. We had a microprocessor. This microprocessor had address, write, read, and data. The address is 16-bit, whatever it is, and data is 8-bit. That's what we thought. This is a very fundamental for us. So from this fundamentally we started building everything. Today, all the softwares what you write are going to be executed by this guy. And another beauty is, for you, this could be anybody, Intel or ARM or PIC or RISC, whoever it is, or Atmel, whoever it is, it doesn't matter. For you, it's all immaterial because you are going to write a program in C, and that is going to come on a compiler. That is going to be done by the compiler, and it's going to come here. So there's nothing more than that. If you use Intel processor, you will get Intel code. Everybody will compile for their own. That's actually a translator. You speak in English, there'll be so many translators. Tamil, Hindi, German, Telugu, everything. So you speak on English, this guy will translate it in Tamil. This guy will do it on Hindi. This guy will do it on German. This guy will do it on Telugu, whatever it is. Now, the same way, these guys, you have various. So effectively, once you know what the microprocessor does, then all your focus should be on C. That is the reason why all the companies say that one word always good in C programming. Okay, that is, you can see that all the job requirements, they will ask one thing, good in C programming. And they also wanted you to be good in all the electronics. Okay, that is the advantage. If they don't ask that, if they say that only C programming, then you lost the opportunity. Because they ask something extra, you should know about electronics, you should know about the I2C, SPI and all the buses, everything. Fortunately, you have still the electronic jobs are with the ECE students. Otherwise, these jobs would have gone to like today. How is the IT? Is anybody can go. IT fieldman, you make civil, BSc, BCom. Even some companies are taking +2. You know that there are companies like a Zoho, everybody they take a +2 and train them. Now there's a company is training beyond 8. Beyond 8, they are trying people for software after 8. Okay, so there's a lot of things are going on now. So the problem is only one problem, not here. These are all simple. And we have also discussed that we have a here controllers. Which makes your job much, much easier. Okay, which makes your job much, much easier. Like functions, you have a printf. The printf had to be written by you to display on the screen. Then you will never learn programming at all. That's the most complex function is the printf. Understand? And if you have to write a printf to do the thing, you can also, somebody has given you the library function for printf. Now the same, see, please understand one thing. The industry is for making money. Okay. They never look for whether you learn or not. That is secondary priority. What they want is you deliver. They don't really bother how do you deliver. But that has to be within a system. If you find that you cannot deliver in 2-3 issues, then they will throw you out. That's the thing. You have to deliver. That is what we are fighting now. Now, why I have taken the topic is this. I told you that this microprocessor gives address based on the clock input. If a clock is 1 megahertz, then I give the address. I have so many clocks. On the first clock, I put the address. On the second clock, I put the data, the read signal. On the third clock, I accept the data. Understand? So I take 3 clock cycles. It's an example I told. Okay, don't take it. It's vary from microprocessor to microprocessor and everything. These are all the things you have to see in the timing diagram. That one day we will see that. We will see that how to understand the timing diagram, and that's a very critical information are there on that. Now, what is happening? This running at 1 megahertz. So the whole thing takes about 3 microseconds. So I design the hardware now, a controller, which will accept this timing, which will accept the timing. That is 3 microseconds. Because 1 clock is 1 microsecond. Because 1 megahertz. Let's say this is an Intel processor. Suddenly Intel thought, hey man, 1 megahertz is too slow, man. I'm not able to execute. So Intel now increase the clock speed by 10 megahertz. Whatever Intel increase the clock speed by 10 megahertz. Now, that means that this time is now 0.1 microseconds. 0.1 microseconds. And this is become 0.3 microseconds. Whereas your controller, what you have designed, is working only on 3 microseconds. So if you put your old controller with the new Intel chip, what will happen? It will not work because he needs 3 micro. It's a very, very, very slow device. Yours is a fast device. Now you see problem. Because of this guy, if you change your controller, then the cost is increasing. At the same time, because of controller, you don't increase the speed, you lose the performance. You have 2 problems. If you want a higher performance, you have to increase the clock. At the same time, if you increase the clock, the timings are going to change. When the timings are going to change, the controller is not going to be compatible with your present microprocessor. Okay. So people thought what to do. So initial days, they were changing the controllers. Okay, that is our, I'm talking about 40 years back. The speeds are not much increasing because they know that if they increase the speed, they have to change the whole, nobody will buy it because the controllers are running at the slow speed. Okay. That is a time they thought something so interestingly. Understand? They, in between this, your microprocessor, or we call CPU, or we call host, he's the one who is controlling the whole thing. And in between, they have a block. The block, this will run at this side. This block left side run at 10 megahertz. Whereas this guy runs at 1 megahertz. Left side is fast device. Right side is slow device. Board is lagging. Yeah, I cannot help it. Nowadays, there's not a problem. Even today, the net people came and I'm having a very comfortable connection from ACT only. They were coming and doing it. They have checked even today morning. They came and checked. Let me once again report them, or I'll change it to some other vendor. I couldn't. So this is happening only the last few days. I need to debug the issue. But there's a surprise. I don't know whether, how do I see that? I see it from local only. You are correct. You are right. I did a mistake. Thanks, man. I'm doing. We found a solution, but still I forgot. Thanks a lot. Yeah. That's a good. Always never hesitate to tell me the thing. Yeah. Now that is what we found a solution. Still I forgot. I think he's having some bandwidth problem. Also, I found very interesting thing. When I remove the host picture, the presenter picture, the sizes become small. Actually, when I display only the board, the sizes become small. So why should I have to see my face? We know that each other, so we can remove it always. That's a good man. Thanks. Now see that. So this is a block which is left side is 10 megahertz, right side is 1 megahertz. This is called bridge. They call it the bridge, which connect the fast processor to slow one. Tomorrow, the microprocessor change it to 100 megahertz. I don't know. I have to change only what. Let that guy be 1 megahertz. I will change only the what, the bridge. I need not to change the controllers. I need not to spend the time, money, and everything. I will change only on the bridge. Okay. You could have heard these things, but we'll discuss later. You would have heard something called North Bridge and South Bridge. We'll discuss these things later. These are all there in your PC motherboard. You're slowly coming in. So you will start hearing about a lot of terminologies. So the bridge is the one which connects a high speed, low speed. This side is called host bus or proprietary. Proprietary bus. This side is proprietary bus. That is, if that Intel released microprocessor, this bus will be proprietary of Intel, which you cannot connect any available device. This is called standard bus. So now I will remove all these things. I will remove all these things. Okay. I have a CPU. I have a controller. I put controllers. You can have any number of controllers. Now, this is called host bus, which is proprietary. And this is the standard bus. What is the advantage of standard bus? What is the disadvantage of standard bus? What is the advantage of host bus? What is the disadvantage of host bus? The advantage of host bus. Maximum speed. So whatever the latest technology in the company that Intel or ARM they make sure that CPU works at the maximum frequency. They never worry about anybody. They keep on increasing. That is the reason only after they found the bridge, the CPU speed start increasing. Now you have gone up to gigahertz. And when they started doing this proprietary bus, the disadvantage of the proprietary bus is not compatible with old devices. Okay, that means that whenever you do the latest one, CPU, you have to change all your components. That has become too expensive. Okay, so also the designer will have to do the whole design, testing. It's a big cycle. So I cannot get the hardware ready. Now, see the case of with the help of standard bus, the advantages. Okay, cost. The company which produced controllers. Okay, see, for example, now Intel released a new CPU. Then the controller started manufacturing the new controller, LCD controller. Then before that comes, you cannot use a CPU. But now the advantage is before I get the latest controllers, I can able to increase the use the latest CPU. That means that I'll be able to hold the controller, but only thing is I have to change the bridge. Bridge is the one which this side, the address, data, everything will be running at 1 megahertz. I told you example, which is various speeds. Okay. Do you understand this? Why we have standard bus? The standard bus is everything same. You are going to write into the memory. See, ultimately ultimately only one thing there. See, please understand the final goal. The final goal is these controllers have some registers. You need to write into the register. That's the only thing. But do I have to write it slow or fast? That's a trick. I say that CPU say I want to write fast. The controller manufacturers say that, oh God, because of you change the CPU, I cannot change the controllers. You have a lot of money, man, you do it. But I don't have a lot of money. Then I cannot do that. That's the problem. To solve the problem, we have a bridge. The bridge is the one which take the high speed signal and convert it to low speed signal. So till the time I do it, I'll wait. No problem. I cannot wait. I cannot do anything. So even though CPU is faster, when it's trying to do the bridge, it's slow. But what is the advantage of CPU now? Now I'll tell you now. I'll tell you now. I have a CPU. And I have a bridge. And I have a controller. This is slow. This is fast. Now you think what the CPU does most of the time. For your example, I'm telling you systems, they do with the memory. My CPU, that is the microprocessor. Sometimes we have so many terminologies, CPU, microprocessor, host. So don't worry, all of them are microprocessors. Okay, the microprocessor have so many names. Now, this microprocessor, most of the time read the instruction and your program, maybe 99% of time with memory. 1% of time with controllers. Because the controller is an intelligent guy. If you give a command, he's going to do the work. He's not going to worry about that. The trick is that you do 99% of time with the memory. Okay, so what happened? If we make this one on the high-speed bus, if you make this one on the high-speed bus, processor will be executing fast. Fetch and execute fast. But whenever it is accessing controller, it becomes slow. So this is what the typical design. The typical designs are like this. We'll discuss about what is the standard buses. That don't worry about that. Okay. Is it clear? If you this is what the general concept of why the bus came. You heard about today I2C, SPI, and what do you call PCI, USB, UART. Actually, UART is not the bus, but nowadays we added along with the thing. UART came for absolutely different purpose. Okay, but we also added to the this one, the bus. We start using UART to do the same activity of I2C and SPI. So these are the ones here. But this and this are different. Please understand. Okay, so now you could have got an idea of how the microprocessor keep on changing new microprocessors. For example, let us say this is a PCI Express or USB. Okay, whether I use Core i3 with 2 gigahertz or Core i7 with 4 gigahertz It doesn't matter for you. How much speed I'm writing, it doesn't matter. All you have advantages. This gate takes care of that. Okay. So this will be running at same speed. That is why you plug the USB device on any system. It is running at the same speed. So you do not have to change the USB. If a USB starts changing based on the machine, then one USB will not work on the other USB. That when controller speed is greater than CPU, the controller has to wait. No problem. CPU will be only slow. You'll be wasting the controller. That the problem is the designer's mistake. Some designer who does not understand how the logic work. I know that I need a person who will do the job. Let us say I have two people. One guy will do a job in one hour. Other guy will do a job in 2 hours. I have two people. One guy will work for 1 hour a job. One guy will complete the work in 2 hours. This guy is asking a salary of 20,000 a month. This guy is asking a salary of 10,000. Now, I want the work to be completed in 3 hours. I want the work to be completed in 3 hours. If I recruit this guy, he will complete the task in 1 hour. Then he will sit idle for 2 hours. This guy will do it in 2 hours and sit idle for 1 hour. I can save 10,000 rupees. You know, the company recruits people at different thing. Even though you are sometimes highly qualified, they recruit somebody. The reason was this. Here also same thing. We don't use the high-speed controllers for the low-speed CPUs. We never do that. I rarely seen that this combination. There is a system in the world. Actually, I know that. I have to tell you the very important thing. This is a process. This question generally happens to Indians. I got surprised when I went to US first. I went to the shop. They said that you can buy a camera, everything. You can return a laptop or everything within 1 month. If you don't like, you can return it. We give you the money back. Even if you use it, don't mind. They will give you the full money back within a month. And I was surprised. All the people accept the system is good. But our people will ask, so when I buy a I go to shop one, I buy a camera for a month and use it, give it to return back. I go to the second shop. Okay, we have a system. Why do you want to break the system? Like that here. We have a buses, everything, to assuming that this is high speed, this is low speed. There's something called you will tend to know later. There's something called system architecture. That is a really good one. That's a really good field. From the requirement, from the customer requirement, then you will select the components and you will get the approval from your boss. And your boss will in turn get the approval from the customer. That they will decide, hey, instead of using this controller, can I use this one? Because this guy charge about $10. This guy charge about $2. If I'm going to make about 1 million pieces, if it is $2 and $10, the difference is $8. So I'll be saving about $8 million. Understand? They don't manufacture a small quantity. They manufacture a huge quantity. Tomorrow, the person who is going to recruit you and give you the salary, all big companies, okay, they will be expecting you to change even every paise. because when they make a phone, they make 10 million phones. If I save 1 paise, I'll save about 1 lakh rupees. Like that. Everywhere they make you that your project. What's this product? It's totally a different logic. Project is proof of concept. Product is implementation. Okay, so we will discuss a little bit about one of the very early days of adoption. Very early days, what they have adopted was your CPU was far expensive. I'm talking about, you'll be very surprised when I'm not talking about 60s and 50s. I'm talking about 1987, about 90s. After my MTech, I joined, and MTech from IIT. I joined at HCL as a senior staff engineer. That time only about few companies, HCL, Wipro, other companies, even Infosys, things were not there. TCS was there. But the trick was, my salary was 1,580 rupees. I'm talking about when 1987. Okay, so even I was the only guy got selected from IIT, even HCL R&D. So you should know that, because these are the information which tells you that how the money is today valued. So think of it, when I say 1987, that is a value. Think of it 1960s. In 1960s, the computers, CPU, used to cost about 1 crore or more than that. 1 crore or more than that. So those days, people had about 100 rupees salary is a great salary. If you draw 100 rupees, you're a great guy. So 1 crore, you can never think of. So what people do is, they have the CPU at the main place, and they had monitor and the keyboard at remote place. This could be at Delhi, CPU. This could be at Bangalore. This could be at Chennai. This could be at Lucknow. Okay. Now, from here, there'll be one wire goes there. One wire comes here. This is called TX. This is called RX. TX. TX and RX. And think of it. From Delhi to Chennai, from a keyboard and mouse, I cannot run thousands of cable. I can run only this cable. Here is a big problem came. When I have to send the data 1, 0, 1 means this, 0 means this. Okay. When they sent this data, what happened was, the wires are long. They have two things. They form like a resistor and a capacitor. They form like a resistor and the wire. So, because of that, if I send a pulse, this gets saturated. This gets saturated. Okay, then it does not goes out for longer distance because of the resistance, the capacitor. They go for longer. You know, you would have heard about called wave shaping. When they have a longer, that will take about long time to charge. If you have a resistor is more resistor and capacitor is more, then it will take till longer to charge. It will take till longer. So based on this, we will discuss about in analog electronics. What is the behavior of capacitor? Now I'm telling you for some important reason. So because of that, what happened? They had used a small device here. I'm trying to introduce a lot of terminologies where people will ask you and you should know that. They have a terminal, they have a, they have a small boxes. This is called, when I'm transmitting, this is called modulator. This is called demodulator. So the advantage of modulator and demodulator is they convert your square wave into sine wave. What is the advantage of sine wave is the moment I send it through the wire for longer distances, the capacitive or inductor effect does not affect the sine wave. It becomes either once again sine to cos. Once again, cosine is also sine only. See, there's no difference between sine and cos. Sine and cos are same. The only difference is the sine wave will do this, cos wave will do this. So there's a small shift. That's the only thing, 90-degree shift. So the receiving side, we will do the demodulation and we get the data. Same way, from that I am sending, I send the digital signal, I'll convert it to modulation, then I send it out. Then I get the digital here. This is called demodulator. That's why they call modulator, demodulator. They call this together as a modem. Okay, modem's purpose is to translate your digital signals into analog signal. Okay, understand this important because I have two connections that comes here now because if I have a short distance, I can able to transmit on directly. If I have a long distance, I use the modulator for demodulator. Generally, all our things what we are using, we're going to use SPI, I2C, and all of them, or generally without modem. They use for shorter distance. Whereas this guy, UART, which came for longer distance. That is what I told you that I have a computer in Delhi. I have a monitor and keyboard at Bangalore. This monitor and keyboard is called terminal. Monitor and keyboard is called terminal. And Delhi is the one we call CPU. So right now in your laptop, in your computer, everywhere at your house, you see everything together. But the olden days, even I just started that time. That time only 80s, we could able to see the thing. Before that, they were having only this. That is the reason the UART came. Okay, universal asynchronous. Actually, its original name is different. UART. Universal, synchronous, asynchronous. That's why they call the word universal. It's a synchronous, asynchronous, receive and transmit. But later they changed only to asynchronous. Universal, asynchronous, receive and transmit is now the meaning of it used everywhere nowadays. It's the long run everywhere. They have to do that thing when I'm selling a second. So, what is? Let us. This is a very old bus. Very old bus. Even today, you are using it. For example, you are having this Atmel. This one, 80. What is it? 398. I don't know the IC number. I forget it. The Atmel chip, 398P. I think 398 or whatever number. I don't remember the numbers. That's very unfortunate. So this chip, 328. Sorry, 328. Thanks. Okay. So this chip are very old. They communicate with only UART. What they don't have? They don't have a USB. This chip don't have a USB at all, like your latest ARM controllers. This guy don't have a USB at all. What we do here is, but whereas your laptop, the original days computers, the computer, IBM computer, they had TX and RX. We were connecting directly. But today, the computers don't have TX, RX. They don't have a UART. They have only what? USB. What they have? USB. But here, there's a chip which converts your USB to this one. RS, this one. I'll explain to you about later what is max 232. There are small numbers. See, whatever we need to use practically, I'm trying to explain, not the more thing. The UART is a very tricky. You need to, you cannot get away with UART. You better learn the UART thing, and they do ask in the interviews also. So once you understand UART, then you can understand about SPI and I2C. Why I have taken up a UART? It's a very simple. Okay, it's a very simple. What it does is, I have a place to transmit. I have a place to receive. It's one of the easiest to understand. That's why I started off. Now, assuming that you have a switch. Okay. And assuming that guy is having a bulb. Assuming you have a switch and you have a bulb. Okay. Now, when I press the switch, I get here bulb on. When you release it, the bulb is going to be off. Am I right? This is very simple. But the beauty is, most of your, not most, all your buses, that I2C, SPI, PCI or USB, PCI Express, whatever it is, all are operating the same principle. So better, once you understand this, you can be able to understand everything. So spend some time to understand this. And the interviews, they will ask, what is the advantage of synchronous bus over asynchronous? And what is the advantage of UART versus I2C. Sorry. They will ask, what is I2C or SPY which you would prefer? You have to have an answer for everything. So basically what I'm trying to say is that what are the common questions they ask, the terminologies. You should not fumble in the interview. You should know all the terminologies. But I only introduce the terminology. It is your job to read more and grasp, get a grip on it. Okay, what you spend your time on reading, I cannot have a control. Okay, this is what the one which started actually. This is a very first standard communication between the two devices. What happened was, it's a very, very easy to understand one. When I press the button, like bulb is on. When I release it, the bulb is off. That is what the most important thing on the this connection. This is called TX, this is called RX. I have two wires. Okay, so please understand all of them. TX, RX. Okay, and then now the problem is I want to transmit a number. Let's say binary. The easy way to transfer any number is, say I want to do 50 times. I want to transmit 50. If you want to transmit 50, I'll be able to do the switch 50 times. Okay. But unfortunately, if you do that 50 times, then it will take very long time. So people have found out that let us make this guy effectively. So that's why they call this a coding. This came even before that. You would have heard about that called Morse code. The Morse code is the one which they use it called very important communications. Okay, there's a huge group is there for the thing. Now, that's why they start using this also code. Now, for a number 5, I'll say 0101. So I press the switch here, that guy get 1. I release the switch, I get 0. When I press it, I get 1. When I release it, I get 0. See that? So I press the switch, the bulb is on. This guy put 1. When I release the switch, this guy is off. I put 0. When I press it, I get on 1. When I release it, I get 0. So I got 0, 1, 0, 1. I could transmit 5 so easily. Done. Now I transmitted 5. But I want to transmit 6. What happened? How do I transmit 6 now? 5 I did it so easily. Now I want to transmit 6. How do I do that? Starting with what? Bulb is off. The bulb is off. Okay, so that means that you cannot on it. The moment you on it, you put 1. That guy put 1. Then you on it 1. Then you off it. So no on. This is still on. Then you off it 0. So see that what is happening? Your intention was to transmit 0, 1, 1, 0. But what he got 0, 1, because initially this is 0. So your switch is off. So our man thought it's 0, nothing. You are not doing anything. Then you press the switch. He got on 1. Then after 1, you keep on pressing. Then you make it 0. Then he got 0. That's what he got it. So to avoid the problem, what the engineers thought, a simple thing, before start, there is something called wake up. So you need to understand this, because these are all the typical thing comes up everywhere. Okay, start and everything will come up everywhere. All the buses, what we are going to discuss in future. Today I'm starting with a very simple call. What is meant by standard? That is what the trick. We'll be using that. Most of the time you will have a problem on that. That is what I've taken, a very, very simplest and the widely used one. Now, when you do wake up, that is, I on the switch. When I on the switch, it become 1. But that guy will think this is a wake up. So he will not take the 1. He will not take the 1. Then you transmit 0 now. Oh, he got 0. Then you put 1. He put 1. Then still 1 is 1. Then 0. So you transmitted, even though with wake up. Now, when you don't have a wake up call, that guy assumes as a 1 0. Now, with wake up, now he improved. He got this, but still, unfortunately, he did not do that. Then there was agreement between the people. When you do wake up, afterwards, everything will be only 1 second. See how we are getting a standard agreements. This, you cannot violate the agreement. If you violate the agreement, 2 chips cannot communicate in electronics. That is what we call standard. You need to thoroughly understand the standards. And they are not as difficult as everything. Once you understand the UART, you will understand everything easily. Okay. Now, see here, I on it for 1 second. So that guy took it 1, but he knows that this is wake up. This is agreement. He will wait for 1 second. After 1 second, he will check the bulb. Oh, now it's 0, man. Because you put 0 for 1 second. Then he'll put it. Then you put the 1 for 1 second. So this is 1 second. 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 Now you spend how many seconds? 5 seconds. 1, 0, 1, 1, 0. Because you spend 4 seconds here. Now you understand. Now you put the on for 2 seconds. Because of that, he took it as a 1, 1. Because our agreement is 1 second. So if you put the 2 for 1 for bulb is on for 2 seconds. And previously, when you don't have the agreement of timing, then what happened? Unfortunately, our man took it as only a 1, 1. Now he has taken a 2, 1. Am I right? That is fine. Okay, so still they had a small problem. The problem is you are trying to do 1 second. By mistake, I am slightly, I'm doing it with 0.5 seconds. Okay, by mistake. How do I, both of guys will know that we are at the same speed? He said it's not possible. Then what they have done is, how a wake up is there. I end with 0. I end with 0. So that means that if you could do that, why I'm explaining this is a reason for it. If you people could able to connect 2 microcontroller board and do this in a software, this UART can be done in a software. If you could do that, TX and RX, okay, and you communicate using this standard things, you have done, man. You'll thoroughly understand. Lifelong, nobody will take you. This will take about maximum 1 day. 1 day. I will tell you how to do that. I will tell you there are methods for implementing. You know one thing, you can implement I2C, SPI, UART, all these things with the help of software. with just the IO pin. I can take a microcontroller. I can take a microcontroller, two IO pins. One is TX and the RX. The two IO pin. One is output, one is the input. I can write a software to convert a UART. That means that just the GPIO pins, passive pins, you can do wonderful UART. These are the things, a small project which I want you to try it out. Then I will tell you how to test it. That is the most important. Do it and test it. These are the things will give you initially a small start. But afterwards, you go, man, you know that because you have done it through software, you will never forget. Even in interview, you can say that I have implemented I2C and UART and SPY in software. You can write that as a resume. Understood? That people think that, oh God, this guy implemented the I2C. See, there are two things. What I'm trying to say is that it's very clear. See here, I have a UART controller. I have a UART controller. I don't know the start, stop, everything. I tell him a transmit 55. I am the CPU, microprocessor. I tell him transmit 55. Now this guy will transmit 55, that guy will receive, and that microprocessor will receive. That's it. In that case, you don't know how the controller is transmitting everything. You don't need not have to know. But what I'm trying to tell you is that 99% of people which coming in the interviews, they don't do this. They use only this controller because all your latest, see, you know that we always try to take the easy route. We always try to take the easy route. Okay, that's the problem. Now, for example, in your, and if it's going to take months together, I will not tell you. These are going to take days, only 1 or 2 days. So out of so many years of your life, the three things, one is UART, SPY, sorry, I2C, SPY. The three, if you could only implement it using without the controller, using microprocessor GPIO to GPIO, you're done, man. I'll bet. You will thoroughly understand afterwards everything, every bus. And any interview afterwards, you will go, see, you know that what the people are doing after 12th. After 12th, people are taking 1 year gap year and prepare for JEE, then go for IIT. They know that if you spend 1 year also, if you could get into IIT, my rest of life will become better. Or they do prepare for NEET. You should be same thing. Okay, you should be very clear about the same thing. You can do it with software timing. That is what I'm trying to say. You do not have to use a timer at all. You need not have to use timer. That's a very perfect question. You can do it without even timer. Okay. That's so good. That's a perfect. Only delay loop. You can do with delay loops. You are right. You can do with delay loops. Correct. But later, see, do that. That's the way. The first what you do that, the step 1, delay loop. Step 2, timer. Step 3, controller. What is the thing is, how do you know that your thing is working or not? What you should do here is, you connect 2 microcontrollers. One side, let it be your software. The other side, let it be controller. This controller could have implemented the standard one. And this is your software. If you could make it to work here, then you are done. Yeah, industry started following the timer. Okay, you are right. But what I'm trying to say is that first, do not have too many variables. If sometimes the things does not work, your debugging of timer itself will take time. I'm trying to find out, I'm trying to tell you that in a real situation, nobody is using software, they're using only controller. But why I'm telling you is that start with the delay, software delay software, then delay timer, then your software with the controller, then controller with controller. That's a 4th path. Yeah, that time, that's why I'm telling that. Very good. That's correct. Now let us go by one thing. Step 1, delay loop. Step 2, timer. Step 3, software versus controller. Step 4, controller versus controller. Understand? These are 4 steps. If you do that with the debug, that may not work with the controller. When you get the controller, you have to have a timer. I will tell you that how to use a logic analyzer. That time that will be very useful. That logic analyzer also will tell you the standard. No, what I'm trying to say is that you have come to the very good level. Now you have understood about your whole these things. That is basically digital, then memories, then microprocessor, microcontroller. Now along with that, have these things. These things will have an inherent advantage for you inside the interview hall. Yeah, there you will sit straight and start giving answers. Understand? You will sit straight and giving an answer. You will not. Nobody can make you to fool in the spy and IT because you have implemented the software. This will take maximum completing all the thing, man. UART, I2C, and spy. We will discuss about how to implement them. There are methods. If you don't write a software correctly, not like a functions, then you have a problem. If you implement very correctly, then it will take maximum 1 week. Maximum 1 week. Don't tell me that you don't have 1 week time to understand the most used buses of the industry. Most used buses of industry. If the same thing, I'll do it. If you are an embedded guy, I tell you that do it on software. If you're a VLSI guy, I tell them implement all of them in a VLSI controller. That's it. That will give you the good advantage of the grip over the technology. Okay. As you said, this is an agreed. If you say that you side having a different timing, the other side is having different timing, it does not work. You have to be very, that's why I'm telling you that. But don't do it in the olden days. Nowadays, you have about, I told you, 700 rupees, you get a logic analyzer. Just connect the wires, TX and RX. Find out how that guy will tell you that your speed is okay or not. If possible, I'll share you tomorrow. I'll write a program for UART and show it to you that. I don't want to do that because if you do that, then you lose the opportunity of learning. So now we have a concept. One is the place X and Y. I transmit. I do wake up. Then I transmit a data 0, 1, 1, 0. Suppose, how do I make sure that both are running at the same speed? Let us say this guy is watching the every bit at 1 second. I'm watching at 0.5 seconds. So what we had agreement was after completing the wake up and send this data, the last bit has to be 0. By mistake, if you do it at 0.5 seconds, okay, let's say this guy is doing, you are sending it every 1 second. He is looking at every 0.5 seconds. There's no agreement, mistake. But you send 1 for 1 second. He said 0.5. He will take it as a 1, wake up, then 1. Then you send 0 for 1 second. Our man will take it as a 0, 0. Then you send 1. So finished. I have taken the 4 bits. Our agreement is only 4 bits. The 5th bit supposed to be what? 0. What you are sending? 1. So our man will say that there's a framing error. That means that there is a speed mismatch. There is a speed mismatch. Because of speed mismatch, nothing works. So then you have to do that checking. What is the speed? Oh God. That is what nowadays you are calling 9,600 baud. That means that like this pulses in 9,600 pulses per second. Or you can call, but you cannot call that a hertz. We'll discuss about baud. There were three things: hertz, baud, bits per second. They are actually different. All of them are different. But in UART, one wire to TX, one wire to RX. Okay. That's what today we use. I don't want to get confused about simplex, off duplex, everything. This all today we don't use. We use only simplex. UART. The case of I2C, we use only off duplex. The case of USB, off duplex. Okay, we'll discuss those things later. Okay, when we are discussing those things, I slowly start getting into a little bit of terminologies. UART, I2C, SPI. These three are the predominantly used in the industry. Then we'll discuss about CAN and PCI, PCIe. What are these things? USB. You should know that. See, as an electronic engineer, you should know all these things. At least by chance, in the interview, you about 4 people are going. That guy is asking something about USB. You say that what for USB, how it is doing, and what is the difference between USB 1, 2, 3, and 3.1 and everything, and what is USB-C. If you could only explain to them all these things you have done, these are all sometime will be very, very handy for you. Oh God, that guy will think that, see, basically, they are trying to find you some so many positive points. Oh, he has a good reader, man. He has a good reader. This guy could be able to go with the latest technology. What is going on today? What is USB-C? Okay, you know that. Now, they're all simple. They are very simple, but you should know that. You understand? That is what the trick. So, what they have done is, instead of standardizing the 4-bit, they're standardizing with the 8-bit. The first one, wake up, is called start. Then I have a 8-bit. Then I have a stop bit. One start bit, one stop bit, and I have a 8-bit. This is what totally you're transmitting 10 bits. So please understand, if you are going to implement it, I wish everyone implement this. Then you will know that thoroughly. These investments are all the golden investment. They will give you return on investment very nice. Okay, these are all golden investments. Sometime I'll say that you'll say that you have a thing, you buy one as a 8051, one as Arduino. And check if it does work on simulation also, you try it out. Let me also try it out in simulation. If you could be able to make that on simulation, that is very good. Okay, that is fine. That day you learn it. So you'll say you have an Arduino and STM32. Then you understand how to do that both these pulses. Okay, so there's only one more thing which I have to understand, which I have to tell you. This is also today I had a when I started everything, I have a 2 dilemma. Either I discuss this buses or I discuss with hard disk. With what is FAT, file system table allocation. Okay, so what is FAT16? FAT32, what is NTFS, NTFS, all those things I don't explain to you that how exactly the hard disk is. Now you can understand. Now don't worry. I can discuss anything to you because we have the trick is that you may not understand everything now, but if you watch the video tomorrow, you will understand more. You will grasp it more. I know that. Now everything is simple. All these things are only ones and zeros, man. Nothing. Now everything was fine. But suddenly the people have thought, if there's a noise comes, how to identify? How to identify? So people have thought, so using 8-bit, we use only 7-bit. I use a last bit for error checking. Error checking. Using 1 bit, how do I detect an error, man? Think of it. They have allotted 1 start bit, then 1 stop bit. I have 7 bits. They given only 1 bit for you to check the error on. This one is error or not. Okay, because there is some noise or something. I transmit, let's say, I'm transmitting 0, 1, 1, 0, 0, 1, 0. This is what my data. By mistake, due to noise, it goes like this. See that? 1, 1 got changed to 0. That I'll explain to you that when we are discussing about analog in inductor and the electromagnetic things. That is how the electromagnetic signals are. That's called EMI interference. EMI, electromagnetic interference. We'll discuss about those things. Those things really matters. Okay. There are small information. Now, this guy, error checking, they thought they find a mechanism. Yay, you got 0, 1, 1, 0, 0, 1. Now let us agree. Let us agree, including the 8-bit, number of ones should be even. Number of ones should be, that is what we agreed. Now, this is called TX. I'm the guy who is transmitting. Now I have a 7-bit. How many ones are there? 1, 1, 0, 0, 3 ones. What will I do here? The error checking bit, I add a 1. This is what I added. Suppose if I am transmitting this data 0, 1, 0, 0, I add error checking as a 0 because already 4 ones are there. So to add 0 here or 1 here, it depends on number of ones in the 7 bits. That is what our agreement. Our agreement is that. Now, let us assume that I am transmitting this data. So I added 1 here. It has gone there. Because of noise, this guy received, let us say 0, 1, 0, 0, 0, 1, 0, 1. The 1 bit got changed to 0. There's an error. If we don't have the error checking, that might have been missed. Now they see that 1, 2, 3, 4. Our man has found out there are 3 ones, but he knows that as per agreement, I have transmitted even number of ones. Even as our agreement. So he knows that I transmitted even number of ones. I will not do the mistake. But he received only 3. That means that he will tell you that I got a wrong data. I got a wrong data. That means that this guy will not accept it. But by mistake, if this also changed to 0. Now you see, once again, even number of ones. Okay, now I cannot do anything. Now that guy will accept, even though 2 bits are changed. If 2 bits are changed, this guy will think that, oh God, this is the correct data. He will accept 0, 0, 0, 0, 0, 0, 1, 0. What you transmitted? 0, 1, 0, 0. This is what you transmitted. 0, 1, 0, 0, 1, 1, 0, 0. This is what you transmitted, 7 bits. But now what about this bit and this bit? Both are changed. Because of that, our man accept that, hey, there is right data. This is also wrong. But what the engineers found, because of noise, the data changing for 1 bit happens above 95 to 96%. 2-bit modification, 2-bit and more is less than 4%. They said, fine, man, it's only very rarely going to happen. Okay, 96% only 1 bit is changing. They did a good study with so many noise, and they finally found out that that's fine. They accept that this is called, this bit, error checking bit is called parity bit. Generally used in noisy environment. Today, what they have done in our communications, people thought, why do I waste one more bit? What they have done, instead of 7-bit, odd parity or even parity, odd or even. Nowadays, people are using 8-bit no parity. I'm so confident, man. My boards are within the board. There is no noise. This will 100% work. 100% work. So I don't need the checking at all. Then you say that 8-bit at no parity. So there are 3 possibilities. You can have a no parity or odd parity or even parity. And the time. Okay. It's all happened with the initial days. Because of the timing used by the people, they always started with 150 bits per second. 150 baud rate. That means that in 1 second, I will send 150 numbers, ones and zeros. Then they increase to 300. Then increase to 600. Then 1200. I don't mistake. In 1987, I started working in this much. 600 and 1200. Yes. Yes. No, depends. No, the agreement. If the 2 people agree that no parity, then there's no parity. The 2 people agreed. So in that case, they will use all the 8-bit. Then 2 people agreed. The problem here is there is no auto detection. You have to, in the software, you have to enter. The software you have to enter. There's no way they have a mechanism to auto detect. This is all very old 1950s, 60s protocols. They never tested anything called auto testing. So because of that, you don't know whether it's a thing. So you have to set both the side. That's why you have to enter. If you don't enter, if you do enter improperly, then it will not work. You have to be very correct. So the 8th bit, I can have like this: 8-bit, no parity; 7-bit, odd parity; 7-bit, even parity. This is a MSP bit. The 8th bit is a MSP bit. Then they introduced to 2400, then 4800, 9600. They doubled it, everything. 19,200, 38,400. Okay. Then 57,600. Then 100 how much? 15,200. All double. All everything double. Then you say 230, 400. Okay. This all started once. So they want to have a standard, keep it up. That's why the baud rates are always like this. But if you do your own proprietary system, do you what? You can have any speed, it doesn't matter. Doesn't matter. But if you would like to have a standard machine, you will do that. Okay, you will set that's all. Now you know that now in the Arduino, you will say that serial dot begin, you will say 5,900. You will do that. Am I right? You set the baud rate. That is what this. So do you agree this? What is the baud rate? That is, the baud rates can be anything, but both the side has to be same. If this side is 57,600, this side is 57,600. tomorrow we will discuss that how the baud rate auto detection taking place. Nowadays they have a facility auto detecting the speed. The one side you set 5700, other side will automatically detect 5700 and test it. That I'll tell you later. Okay. Don't tomorrow I'll do that. Yeah, that requires a little bit of more discussion. I don't want to do it the fake end of the class. So this is speed. So we set speed in UART. We set first speed. That is baud. Second, parity. When you say a parity itself, then you say third, 7-bit or 8-bit. When you say 8-bit, no parity. When you say 7-bit, odd or even parity. These are information you should give it. Sometime in olden days, people use number of stop bits. I told you, after this is a wake up, start bit, wake up, the stop bit. Sometimes they want to have a gap instead of 1 bit. Sometimes people have 2 bits or 1.5 bits and all. So forget about it. Right now, you forget about it. There's only 1 bit. We agree that. Or you can also mention it, stop bit. Can you have 1 bit or 2 bit? Right now, you agree only 1 bit. Let us have a 1 bit for start, 1 bit for stop. So these are the things you should know that. So this is all about UART. Okay. Next class, I will discuss with you how do nowadays they do auto detection. What is exactly this this one does? USB to serial converter does. Okay. So because every time you plug the USB, that game will tell you that it's a COM3, COM4, everything. What is that? You should know. You should know thoroughly all these things. Not like just like that. Don't do trial and error. Try to understand what exactly these things means. Okay. So since we even now we predominantly use the UART, and we better understand. For example, if you take ARM board and all, you have n number of UARTs. I can have 2, 3, 4, 5, everything. And this is a major advantage also there nowadays. When you try to communicate from your mobile phone, mobile app, Android app to your Arduino or any microcontroller, you have a UART. You have a UART. But you just have to know only UART. But here, there is a converter who will take the Bluetooth and like a USB to UART converter. This is a Bluetooth to UART converter. Okay, in that case, you can write a very good app on the Android phone, and you can able to control your motor or anything with this microcontroller. Okay, you can do it as a hobby, but not fine. Companies will agree you that Android app also is very good. Then it's good. That there are so many methods of doing Android app. We will discuss that later. Right now, I'm not having a time to do that. So now my task is to make you to the into the company. That is what my goal now. So I don't want to give you too much. I'll give you what are all necessary on the interviews. So the most popular one is UART. You should say that I 100% understand. There's nothing called less than these 3: SPI, I2C. You should be 100% understand. 100%. There is no doubt. In that case, any interviews, you will get through this, because all the microcontrollers, CPU, microprocessors, they connect with the devices, controllers. One of this, either UART or SPI or I2C. Okay. And if you go to the automotive, then it's called CAN. That also we'll discuss. Okay. That can, if the time permits, I don't know, that may be a extra one add on, but other ones are all surely we'll discuss. So UART, we have communicated right now only X to Y, two wires. One is called TX for this guy RX. That guy TX comes to this guy RX. Simple. Now, both the people you have to send that. What is the speed? What is this one? That is baud rate. Then what is the bits? What is the parity? And what is the stop bit? You configure them. Then it should work. And tomorrow I'm going to give you a hint how to do this in a microcontroller. Writing a software, how to do that. If some of you could do that, that will be good actually. They all will be always handy when you do long term. You get into the company, your growth will be very fast if you know those things, how to do it. But for this sensor, you should be good at C. I will explain to you that if tomorrow, if a time permits, I'll explain to you what is RS-232. Both are looks to be same, but that is slightly a different one. I'll tell you what it is. We used UART. We used UART for RS-232. That is a right statement. We used UART for RS-232. Am I right? If maybe we take about few minutes, I'll explain to you what is RS-232 by tomorrow. Yeah, nowadays it's absolute. That's why I say that you cannot. Nowadays we have UART is only one thing. RS-232 were used those days with the modem. There's a signal called TX, RX. Then there's a signal called RTS, CTS. Then there's a signal called DTR, DSR. Then there's a signal called CD. See that? I have to explain everything. I don't want, because this is totally, as he said, this is become no, USB is different. God, USB is different. Today USB has gone too high, man. With the USB's data standard of transferring 5 gigabytes, all the too good. USB is totally different. But USB came for this. That's called universal serial bus. The universal came for, they said that, hey God, you don't need to have a keyboard. You need to have a mouse. Everything will be on USB. That's why they came on USB. But today's purpose is gone too high. Today, what happened? You have buy a laptop and have a USB-C and have a Thunderbolt interface that is developed by both Intel and Apple together. Develop Thunderbolt thing. Then you can connect even 4 monitors, 3 monitors, and you can connect Ethernet. You can connect everything. So your laptop will have only one USB-C. You will not have any other thing. This guy will, you have a small box. Okay, you can carry it. This guy will support USB 2, USB 2.0, 3.0. All these things will be supported by this guy. Understand? Yeah, you need to understand, but I don't have time. That is not purview of this talk also. Okay, this is a simple level 1 microcontroller interfaces. USB, CAN and or the second level. Once whoever, that's what I'm trying to collect from all the batches, coming batches. Whoever completed to my satisfaction, I'll take them to the next level. No, I will not discuss the whole ESP program. I will not discuss about USB and CAN. I will give you a top level overview. What is that? There are 2 super bus. I can go in depth, but those things I will do it only for the. I don't take everybody. I will not accept everybody on those programs because that will waste my time. I will take from batch 1, batch 2, batch 3, batch 4, everything. whoever done a good level, maybe about 10 people is enough. I'll take only 10, 15 people. I'll teach them. You have to raise your level now onwards. Otherwise, I will not teach everybody. Otherwise, what happened? Wasting your time, man. I wanted to have a bar set and above that I discuss. If you're discussing about USB, if somebody asks that, sir, how that serial port is working, what is synchronization? Gone. My whole thing is gone. My whole class, that day class is gone now. So please understand that. Let us go in a nice way. That's why I'm going to give a time. I will not start the second one immediately. That is the 7 steps. That's now I'm going to cover on the first two steps. And third and fourth, I'll start it only after some time. Maybe by next year, January, February time frame. Not now. At least I want to have about a few batches. Yeah, actually, a bus is the one. The trick is that why bus? I have a concept is there is a group, there is a road. Okay, on that a bus travels. You wherever you want to get down, you can get down. There are so many stops wherever you want to get down. Like that here in the bus, there are two topology. One is called point to point. Other one is bus. There are two architectures. One is point to point architecture, one is bus architecture. The point, your UART is a point to point. It's not a bus. It's not a bus. It's a point to point. Okay. Now the buses like this. I transmit this way and I can connect multiple devices. I transmit data here. Whichever device want to take, they take it. That's why they call this as a bus. As I told you that's when I say that when I have a microprocessor, when I have a host bus, that goes to so many controllers. I transmit the data, but whoever is having the same address, they pick up. Okay, that's why they call it a bus. Okay, a group of wires and it carries the information. That's what they call buses. Typically, bus means one to many. I can drop down more people. One to one is called point to point. We have two devices. One is called hub. One is called switch. I'll explain to you that if time permits tomorrow. So switches are used for point to point, and hub is used for one to many. Correct. Without address, nothing will work. Yeah, exactly. We'll discuss about that because today we discuss UART. UART is point to point. Only two people are there, Balaji and Ganesh is there. Two people are talking. So Balaji will not say, Ganesh, listen to me. Balaji will say, Ganesh will accept. Ganesh will take, Balaji will accept. Only two people are there. But when if you take I2C, there are multiple people. That time, every device will have an address. That we will discuss from tomorrow onwards slowly. I don't have a time. I told you now, I do not want to put any time limit. If I have a time limit, I don't stick to that normally. Yeah, this is full duplex. That is half duplex. I'll discuss tomorrow when I'm discussing about I2C. I'll explain about half duplex.